Yes, hello, good evening everyone. Welcome to BYJU'S exam prep. So I hope that my voice is absolutely fine. Yes, so I can, yes, absolutely fine. Done, done, done. So please share the session because of some technical issue that session is little bit late today, and we are going to have the marathon session, that is the basics of the signals and system. We are going to discuss around 1.5 hour. This is session is going to be, and in this session we are going to discuss about all the basics of the signals and the systems. Means how to define the signals, what are the different types of signals, and similarly we will also discuss about the systems, how do you define the systems, what are the different type of systems. So all these systems we will discuss over here. Okay, so share the session with the friends. Maximum students will come, then the session will be more interesting because when the most of the students will give input, then it will be a great joining the session together. Okay, so just quickly share the session with all the friends. So as I can see that students are still joining. Yes. Good evening, Bhanu. Good evening, Ayush, Hari Harsadan. So let's start the session with a brief introduction about myself. So this is Saket Verma and I have done MTech from IIT Guwahati, having more than 12-year experience. So now it is 13-year experience and I am teaching these subjects, advanced communication system, signal system, electromagnetic theory, communication system. So in this particular series, mini marathon, I am going to cover the complete signals and system in the next 3 days. Today, we are going to discuss about the signals and systems. Tomorrow, we will discuss about the Laplace Fourier. Then, day after tomorrow, we will discuss Z transform, DTFT, DFT. So, in this way, in this next 3 days, we are going to revise all the signals and system because now in the month of October, there is no one left with the preparation of the signals and system. Those who are seriously preparing for the gate and definitely they have completed the signals and systems up till now. Now they might be thinking of the giving the test series, solving the questions, and also they are preparing for the core subject. So you might be one of them कि आपका भी जो preparation चल रहा होगा that would be for the core subjects or otherwise you might be giving the test series for these subjects. So फर्स्ट ऑफ ऑल अगर हम बात करें तो सबसे पहले सिग्नल्स में बात करते हैं तो सिग्नल्स बेसिकली वी हैव फ्रॉम स्टार्टिंग फ्रॉम द सिग्नल्स ऑपरेशन. There are multiple operations that we perform that can be performed in the signals like amplitude scaling, amplitude folding, time shifting. Time shifting may we have the time delay, time advance, okay, and again then time scaling, time expansion, and the signal compression, and then time folding. So these are the operations that we perform in the signals. So one by one we will understand or revise how do we perform the amplitude scaling. We just multiply with some constant a, then the signal is amplified by the constant a. Okay, so what is the working rule? So signal x of t is just multiplied by the amplitude factor a, and in the amplitude scaling operation width does not change because we are actually multiplying with the amplitude a, so it change only the amplitude of the signal. So suppose this is the signal you have 0 to 5 and the amplitude is 5. Now you are suppose drawing the 2 into x of t, then it will not change its width, it will change its amplitude only. So this is xt and now you are multiplying it with the 2, so 5 into 2 become 10, but the width of the signal is same because you are not doing anything with the time function, so the width will remain same. Now coming to the amplitude folding, suppose you are multiplying with the -1 in the amplitude, then the signal gets shifted. Okay, signal will get shifted here. So like here we will see suppose 1 and 5 here, then if you multiply it with the minus of 1, minus xt, if you multiply, then it will become minus 1 and width will be 0 to 5. Okay. Yes, Hari Harsulan, there will be no problem solving today, and next 3 days we are going to learn only the theoretical part of the signal. So if you want to revise all the properties, everything about the signals, then this session is for you. Okay, now coming to the time shifting and the time delay operation, the time delay, time advancement. The time delay and the time advancements are the two different operations that we perform in the time shifting. Okay, the time shifting will have the time delay and the time advance. So time delay means the shifting the signal towards right. So when we shift the signal towards right, then we call it as a time delay. Okay, and when we shift the signal towards left, then we call it as a time advance. And what is the working rule? So to delay a signal x of t by a, if you want to shift the signal by a, then the argument t is replaced by t minus a. Time delay means shifting towards right on the graph, and time delay means start late. Delay means starting the late. Duration of the session will be 1 hour only, Bhanu. Duration of the session will be 1 hour. In the next 1 hour, we are going to cover the entire signals and systems from the basics of signals to. So mathematical representation of the time delay operation x of t, time delay by a, and if you shift the signal by a, then definitely you will get here, and otherwise you will have the signal towards left. So that is known as time advance. So if you time advance it, so x of t will become x of t plus a. So to advance a signal x of t by a, x of t is replaced by t plus a. The signal advance means shifting towards left, or you can say advance means the starting early. Little bit you are doing something in advance, that means it is starting early. Okay. Now coming to the next one, that is the signal expansion and the signal compression. That is very important one. Signal expansion and the signal compression. It means that signal expansion means you are going to expand the signal, and the signal compression means you are going to compress the signal in the time domain. Okay, and to expand the signal, we actually multiply with some constant in the time factor. Okay, we multiply it with the time factor, right? In the time factor, when you change, then there is a compression and expansion. So that means here the area is going to be changed, the width is going to be changed. So the rule is when how do we represent the signal is xt, and when we scale it, we write it as x of at, and the working rule time scaling of a signal x of t by a means t will be straight away replaced by at, and if the time scaling factor a is less than 1, then it corresponds to signal expansion, and if the time scaling factor a is greater than 1, then it corresponds to signal compression. Okay, so if it is greater than 1, then it is expansion, compression, and less than 1, then it is compression. Now the time folding. So mathematical expression of the time folding. So simply when you multiply it by minus 1 means you are in the compression. If the a become minus 1, then it is known as time folding. So simply replace the t by minus t to get the time folded signal. Okay, and time folding of a signal means a rotation of a signal about vertical axis of about 180 degree. When you rotate it by 180 degree, then it is vertical axis. Okay. About the vertical axis, if you flip it by 180 degree, then it is nothing but the folded signal. Now there are some standard signal. Okay, so there are some standard signals like unit step signal, signum function, unit impulse signal, rectangular signal, triangular signal, sync function, sampling function, exponential function, sinusoidal signal, ramp signal. All these signals you should know about all these signals. All signals are very important and basic elementary signals. Without these signals, the signal and communication are not possible. If you don't understand these signals, then it is difficult for you to understand the signals, and also the it is difficult to understand the detail in the communication also. When you going to perform the Z transform, Laplace transform, Fourier transform, if you don't know these signals, it will become difficult for you. So starting from the unit step signal, how do you define the unit step signals? Unit step signals are those signals which are defined for t greater than 0. Okay, these are defined for the t greater than 0. For t greater than 0, it is 1, and for t less than 0, it is 0. And unit step sequence, this is a discrete form of the signal. So for n greater than 0, it is 1, and otherwise it is 0. And n here is the discrete, means only it is 0, 1, 2, 3. All these values are having value 1, and otherwise it is having value 0. Now coming to the ramp function or ramp signal, the ramp signal is RT, and it is for t greater than 0 it is t, and for t less than 0 it is 0, and RT is also defined as TUT. RT is also defined as TUT, and similarly for the ramp signal R of n is for n greater than 0 it is n, for n less than 0 it is 0, for n greater than 0 it is n. So that is 0, 1, 2, and so on up to infinity. You can put the different values. Now the signal, signum is for t greater than 0 it is plus 1, for t less than 0 it is minus 1. So signum function is denoted and defined as the signum t is equal to for t greater than 0 it is 1, for t less than 0 it is minus 1, for t equal to 0 it is 0. Rectangular signals are the signals having certain width center about origin. So this is the rectangular pulse, a rectangular T, that is having the width 1 and the height is A. In general, the rectangular pulse are defined as A rectangular T upon capital T, right? Where the T is the width of the pulse, T is width of the pulse, and A is height. A is height. So in this way, you can define. If you want to shift it, then you can write it. But if it is not written anywhere, means it is not shifted, means t is not replaced by anyone, then remember that you just have to focus on the center. Origin center should always be in the origin if it is simply rectangular t upon something, where capital T is the width. Yes. Now coming to the triangular signals are signals which which is also centered at 1. It is defined from -1 to 1. So you can write, okay, you can write the triangular signal as T upon T, if suppose. It means that A triangular T upon T, it means that this T is the half width. Okay, it will cut the axis in the point T. This is the height. So A is the height and capital T is known as half width of the pulse. Okay, capital T is half width of the rectangular pulse or rectangular, sorry, triangular pulse or triangular signal. Correct? Here we can write in this form also 1 minus mod T. You can also write it in the form of A triangular T upon T. You can also write it in the form of 1 minus mod T upon T. In this way also we can write for mod of T less than capital T and 0 otherwise. Okay. Hello Maniteja. Yes, Vikram, good evening. So in signals and system, more weightage topic for the electrical. Okay. See, generally it comes from the Z transform, Fourier transform, Laplace transform only. Okay. In the signals, there is periodic signals, non-periodic signals. Only these are the important one. This is about the sync function. So sync function is very important function. That is, sync function is defined as sync t sine pi t upon pi t, and you can define it as like this. Now, if you want to write this sync t suppose, then you have to calculate its where it is crossing the zero axis, where it is crossing the maximum value. So when you put the sync zero, okay, so it is 0 by 0 form. So in the 0 by 0 form, you have to apply the L hospital rule. So limit t tends to 0. This is pi sine, differentiation of sine is cos pi t, and here you will get pi. So limit t tends to 0, it will be 1. So the maximum value will be 1. And if you make it sine pi t is equal to sine n pi, then the point you will get where you will have the zero crossing. So t is equal to n. So here you will have the zero crossing because this pi and pi will get cancelled. So 1, 2, 3, these are the values where you will get the zero crossing. Minus 1, minus 2 because n is here, plus minus 1, plus minus 2 and so on. Now, similarly, the sampling function you can define. The sampling function is a sampling of sine t upon t, and similarly, you can write the sampling of pi t. Suppose sampling of sine, then it will become t is replaced by pi t. So this is sine pi t upon t is replaced by pi t. So sine pi t upon pi t, and which can be written as sinc of t. So here you can see the relation between the sampling and the sinc. Okay, relation between the sampling and the sinc. The sampling pi t is equal to sinc t. right? Is it clear up to this point? Okay. Now, after this, triangle is coming again. Okay. Sync. Okay, this PPT is get repeated. Right. Now coming to the unit impulse signal. Unit impulse signals or the direct delta function. So unit impulse signal or direct delta function is at t equal to 0, it is tending to infinity, and at t not equal to 0, it is 0. The important property about the impulse is its area is equal to 1. So this is showing that the area under impulse is always equal to 1. Area under impulse is 1. Okay, area under impulse is unity. Now the differentiation of the ramp function gives you the unit step, and the differentiation of the unit step will give you the unit impulse. Now coming to the important result, that if you integrate the impulse you will get the unit step, and if you integrate the unit step you will get the ramp. Now, these derivations are not important. Yes. Now, coming to this rectangular part, if you suppose you want to define a rectangular pulse, so this is a rectangular pulse, and if you want to derive it from there, then this rectangular pulse when tends to 0, the width when tends to 0 will become the impulse. Okay, so the property of the impulse is it was even symmetric. So delta of minus t is equal to delta t, and the property of the unit impulse, the area under the impulse is 1. If you integrate it from minus infinite to infinite delta t minus a, then it will give you the value 1 again. And if you integrate it from 0 minus to 0 plus, then also it is showing that the area 1. And if you integrate it from minus a to a minus to a plus and t minus a, then also it is 1. It means that when you integrate the impulse should exist within the range of the integration limit. Here you can see that this a, I am integrating it a delta t minus a. So this is the delta t minus a. And because when I am integrating it from minus infinity to infinity, it is for sure that this impulse will exist in between minus a to a. Hence the total area will be 1. Suppose you are calculating from 0 minus to 0 plus, and your impulse is existing at t equal to 0, that is delta t. So then also the area will be 1 because the impulse is existing within the limit of integration. And what will happen if you won't get it? Then the result will be 0. If the impulse is existing outside the limit of integration, then result will be 0. And product property is that if you suppose multiply the signal with the delta t, x of t is multiplied with delta t, then you will get x of 0 delta t. Means you will get the value at t is equal to 0. If your impulse is shifted, then you will get the signal at t naught. So x of t naught, and impulse will always be there. After that, you will have the property of unit impulse signal, in which we have the shifting property along with the area. So minus infinity to infinity delta t into xt, you will get x of 0 delta t, and because you are integrating, delta t will become 1 and x of 0 will be outside. है We said that x of t delta t is nothing but a minus infinity to infinity x of 0 delta t. Okay, and this x of 0 is a constant. So this is x of 0 minus infinity to infinity delta t. So minus infinity to infinity delta t is 1. So x of 0 we will get. Okay. Similarly, you will get the x of t delta t minus a, you will get x of a. Similarly, you can get the a minus to a plus. This a is existing within the limit, so it is x of a to b, and if this t naught is lying between a to b, then it is x of t naught. Otherwise, it is 0. As I said, if the function is lying outside the range of the integration, then it is 0. The property of the shifting property or scaling property, the scaling property says that if you suppose scale the impulse in the discrete time, in the continuous time, then delta at is equal to 1 upon mod a delta t, and if you do it in the discrete time, then it is remaining same. So delta n in the impulse at n equal to 0 it is 1, at n equal to 0 it is 1, and delta n at n equal to 0 it is 1, and for not equal to 0 it is 0. And coming to this classification, so we have the continuous time, discrete time signal, deterministic and random signal, causal and non-causal signal, even symmetric and odd symmetric signal, conjugate symmetry and conjugate anti-symmetry, periodic and aperiodic, and energy and power signals. So these are the signals type, different signals type. Okay, so after this, we will go into the classification of system. So how do you define the deterministic signal? It has the mathematical expression. Deterministic signals can be well expressed by the mathematical expressions. Deterministic signals are predictable signals, and analytical mathematics theory is utilized for analysis of the deterministic signals. Okay, and if I talk about the random signals, then the random signals cannot be expressed mathematically, and random signals are unpredictable signals, and more probabilistic mathematical theory is utilized to analysis the random signals. Guys, one more thing that I would like to tell you, that in the description there is a scholarship test, open mock test we are providing, and the link is given in the description. You can register yourself for the All India Open Mock Test, that is for free for all the students, and there is also link for the app. So if you download the app, then there are multiple free sessions we are taking. I am also taking, and my colleagues are also taking. Our team members are completely giving you free of cost some special concepts, and everything which you are looking for, maybe for the scholarship, maybe for anything else. Every link is given in the description, so you should go through it once. Okay, for the crash course, if you want to enroll for the crash course, then also it is given in the description. Yes, Rushikesh, thank you. Now, the causal and anti-causal and the non-causal signal. Causal signals are those signals which are 0 for t less than 0. Anti-causal signals are those signals which are only defined for the t less than 0. And non-causal signals are both-sided signals which are defined for positive and negative side both. So right-sided signals for t greater than 0 are causal. Left-sided signal for t less than 0 it is non-causal, anti-causal, and then non-causal signals are both. So causal and anti-causal are reversal, and causal signal multiplied with any non-causal signal will always be causal, and non-causal signal multiplied with anti-causal signal will always be anti-causal. Okay, and causal signal multiplied with the anti-causal will become some finite value, and causal and anti-causal if you add, then it will become non-causal. Now the periodic signals are those signals which will be repeating themselves after certain time period. So here you can see that the signals are repeating themselves at after t equal to 1. After t equal to 1. Here you can see these are defined. Okay, after t equal to 1, they are repeating themselves. It is starting from here, and this cycle is completed, and then again it is repeating. So this is a periodic signal. A signal which repeats after finite duration is called the periodic signal. The finite duration of the time after which it repeats is called the period of the signal. Okay, after every time period, if it repeats themselves, then it is called the time period of the signal. Periodic signals. And what are the fundamental period and the fundamental frequency? So if the t is the time period of the signal, then 2t, 3t all will be the period of the same signal. The smallest possible value is known as fundamental period, and the reciprocal of the fundamental period is the fundamental frequency. For a signal to be periodic, the signal must have exist between the minus infinity to infinity. The signal should exist between minus infinity to infinity. Now coming to the addition of the periodic signal, if you add the two periodic signal, then the linear combination will also be periodic with the time period. If they are periodic, then should have the T1 upon T2 is equal to M by N, that is a rational number. Okay, so this is LCM of numerator and SCF of denominator. Okay. Then after this, if suppose you are talking about the discrete time signal, so discrete time signal will be periodic with the time period if the 2 pi upon omega is a rational number. If it is a 2 pi upon omega is a rational number, then it is a periodic. Sorry. Bishwajit, today we are only discussing the theoretical things, means we are revising it. It is just a revision, you can say. In the form of mini marathon, I am providing you the revision of the session, not the numericals, because numericals I have already taken in this month only. 2 weeks before, I have taken the three consecutive sessions based on the new questions, not the previous year questions, new questions of signals and systems. Similarly, after this revision series, again in the next month, I will come up with some question series. There, I will discuss more questions of signals and systems, other subjects also. Now coming to the even symmetric signal. So if the x of t be a signal such that x of minus t is equal to x of t, then it is said to be uh, even symmetric signal. And even symmetric signals, when you uh, see the vertical axis, about the vertical axis, it is mirror image. Symmetrical about the vertical axis, and it means that the either symmetrical in the first and second quadrant and the third and fourth quadrant. X of t be a signal such that x of minus t is equal to minus of xt, then it is called as an odd signal. And odd functions are antisymmetric about the y signals, and the total area of the odd function is 0. Now going after this odd symmetric, this is an example of odd, and here you can see that the area is going to be 0. If you suppose calculate the area, then it is 2, and if you calculate area here, then it is, because in the negative half you will consider 1 by 2, width is 2 minus 2, so it is minus 2. So this is minus 2, this is plus 2, the total area is 0. The width is 2 and the height is minus 2, and actually below the origin you will take as positive, below the origin you will take the area as negative, and above the origin you will take the area as a negative. Then you will get the total area always 0 for the odd function. And discrete time even symmetric signal. So a discrete time signal x of n is said to be even if x of minus n is equal to x of n. Discrete time even signals are symmetrical about the vertical axis. A discrete time even signals is shown in figure. This is the discrete time signal which is shown in figure. Odd symmetric, again x of minus n is equal to minus of xn, then it is an odd symmetric signal. Discrete time odd signals are symmetrical about origin as shown in figure. So here you can see about the origin they are symmetrical. This is symmetrical in along this axis origin. Now, even and odd component, how do you calculate the even and odd part of the component of the signal? So you take the x of t and the folded version and then add it, divided it by 2, you will get this. So x even, any signal is defined in terms of even and odd. Any signal can be written as a sum of even and odd. Xe is the even component of the xt, and x naught is the odd component of xt, and even component of an even symmetric signal is itself an odd component of even symmetric signal is 0. Okay, when you calculate the even component of even symmetric signal, then obviously you will get the even signal itself. And when you calculate the even part for the even symmetric odd component, then it is 0, because it is even signal. Then how it can be the odd signal? Similarly, even component of odd signal will be 0, and odd component of the odd symmetric signal will be the signal itself. Now coming to the even and odd component in the discrete time. Similarly, in the discrete time also you can write the sequence in terms of the even signal and the odd signal. So this is conjugate symmetry and conjugate antisymmetry. So if a signal is complex in nature, then x complex conjugate of minus t is equal to x of t. Then x of said to be x of t says said to be conjugate symmetry. And if the signal is written in the form of x of t is equal to a plus jbt, for conjugate symmetric signal, real part of at is even and the imaginary part of bt is odd function. If it is conjugate symmetry, then the real part is even, then odd part is imaginary part is odd. If it is antisymmetric, then the antisymmetric means if you take the complex conjugate and fold it, then you will get minus of xt. This is known as conjugate antisymmetry. So this is x of t is equal to at plus jbt. Then here for the conjugate antisymmetry, the real part is odd and imaginary part is even function of time. A given complex signal can be always be splitted. A given complex signal, like any signal, can be splitted into even plus odd. Similarly, any complex signal can be splitted into the antisymmetry and the conjugate symmetry. So these two components we can always divide a signal or split. So x of t is conjugate symmetry and conjugate antisymmetry, we can write. And how to calculate this is x of t and plus complex conjugate of minus t divided by 2, like a even component. For the even component, how do we calculate? To calculate the even part of signal, we used to calculate x of t plus x of minus t divided by 2. Similarly, here we have to just take the complex conjugate and then x of minus t divided by 2 will give you the conjugate symmetry, and for conjugate antisymmetry you have to subtract it. You have to subtract x of t minus x of complex conjugate of t minus t divided by 2 will give you the conjugate antisymmetry. Now, similarly, in the discrete time also, the conjugate symmetrical, any signal can be splitted into the two parts, that is conjugate symmetrical sequence and conjugate antisymmetrical sequence. And the same way we calculate x of n plus x of minus n complex conjugate divided by 2 and x of n minus of x of n minus n complex conjugate divided by 2 will give you the conjugate anti-symmetry. This is the conjugate anti-symmetry. Now coming to the energy, how do you calculate energy of a signal? So if you want to calculate the instantaneous power, then it is simply x square t. And if you want to calculate energy, then you have to integrate it from minus infinite to infinite x of t mod square dt. And if you want to calculate the power, then over the time period 1 upon t integration over the time period x of mod t mod square dt limit t tends to infinity also you can put. This is the average signal power. So what are the important properties? If you suppose want to calculate in discrete, then also you can calculate. This is simply summation n equal to minus infinite to infinite x of n mod square, and time average power is limit n tends to infinity 1 upon 2n plus 1 summation n equal to minus infinity to infinity, sorry, n equal to minus n to n because it is periodic na. So it has the period n, so it cannot be minus infinity to infinity, it should be minus n to n, and whatever will be the range of the summation, that should be divided here. So 1 upon 2n plus 1, because minus n to n there are 2n plus 1 numbers, 0 including 0. So that is why 1 upon 2n plus 1 summation n equal to minus n to n and x of n mod square. Now, for energy signal, energy will always be finite, the power will be 0, and for the power signal, power is finite and energy is infinite. So for power signal, energy is infinite, power is finite. Important point about the energy signal and the power signal. So is it clear up to this point? Just repeat once. Can you comment in the comment section that everything is fine up till now? Quickly comment in the comment section that whether you have got it or not. Yes, yes, Manoj, Banu, yes. Okay. So the all finite duration bounded signals are energy signals, and all bounded exponential signals are energy signals. Both sided bounded exponential signals are energy signals. Energy signal is having the finite energy power 0. Energy of the power signal is infinity, and their average power is non-zero finite value. Periodic signals are always a power signal mostly, and a signals cannot be both energy and power simultaneously. So we cannot say a single signal as a both energy and power. Now bounded exponential signal. What is the energy in the bounded exponential signal? So e to the power minus 80 ut. How do you calculate? So energy is simply 1 upon 2a. What is the energy of such kind of signal is 1 upon 2a. That is the energy of the bounded exponential. And the bounded exponential in the left hand side, that is also having the energy 1 upon 2a because it is the left hand side. If it is both sides, then it is 1 upon a. So you can see that this, if it is both side exponential, then it has the energy 1 upon a. Now unbounded exponential will have an infinite energy. Okay, this is not going to repeat, and energy will be infinity. And for all these unbounded signals, the energy is infinity. For a rectangular signal, it is a square into t. This is the energy of the signal, a square into t. For triangular signal, we can write a square t by 3. If it is this type of triangular signal, then the energy is 2a square t by 3. If it is t and minus t, and this is how it is a. If it is a half wave sinusoidal, then we can calculate as a power. The power of the signal is a square by 2 for a sinusoidal signal, and if you multiply it with time, then you will get energy. So that is why its energy is a square t by 2. And what is going to be effect of the operation? If you perform certain operation in the signals, then what will be the change in the energy? So if you shift it, energy is not going to change. If you shift or advance it, then also the energy is not going to change. You are folding it, not going to change, because the energy is actually the magnitude square. Energy, when we calculate, we take the mod of the signal and then square it. So that's why energy is not going to change if you simply change the time factor. If you do any manipulation with the time, there is not going to change energy of the signal. But if you change the amplitude of the signal, like amplitude scaling, if you perform, then it is definitely going to change. So here you can see amplitude scaling is going to change the energy. Time scaling is also going to change the energy because the limit will be changed. So that's why the width will be changed and the folding is not going to change the energy of the signal. Now coming to the system part. Now coming to the system part. So this is the classification of the system. Static versus dynamic system, causal versus non-causal system, linear versus non-linear system, time invariant versus time variant system, Bibo stable system, and invertible and non-invertible system. Is it okay? Is it clear up to this point? Yes. Now, static versus starting with the linear and non-linear. So, a system which obeys the superposition and homogeneity both, then it is called linear. So, superposition means additive and homogeneity. So, superposition itself means the homogeneity and additivity. So, homogeneity means simply amplitude scaling, and additivity x1. If suppose there are signal x1 and x2, then if you add them, you will get the addition of the signal. So overall, we can say that if alpha x1t plus beta x2t tends to going to give you alpha y1 plus beta y2. Then effect of DC component on the linearity of a system. System become non-linear. System become non-linear due to the presence of DC component in the input-output relation. DC component are also referred as initial condition. Now the system become non-linear due to the presence of DC component in the input-output relationship. जैसे कि suppose करो y is equal to ax plus b वाला situation है. So in this, because of this DC component, this system will become non-linear. DC component are also referred as initial condition. Effect of amplitude scaling. So linearity of a system is never affected by the amplitude scaling of any term in the input and output relationship. Amplitude scaling factors are also referred as the constant coefficient terms. Effect of nonlinear terms, system becomes nonlinear due to the presence of any nonlinear term in the input output relationship. So in the input output relation, if it is linear and if you suppose add any nonlinear term, then it becomes nonlinear. Then linearity of a system is never affected due to the presence of any time coefficient term in the input output relationship. So any function of time, if you multiply, then it is not going to affect. What is the basic effect of basic operation? This was just adding the DC signal nonlinear term. But what happens if you suppose delay the signal, advance the signal, compress the signal, whether the linearity will change or not? So the time shifting, delay or advance does not affect the linearity of a system. Time scaling does not affect the linearity of system. Amplitude scaling does not affect the linearity of a system. Time folding does not affect the linearity of system. Amplitude folding does not affect the linearity of system. That means amplitude is not going to change. Means any operation. Time shifting does not affect as we discussed. Okay, now the time variant and the time invariant. So if a delay input is applied to a system and output also get delayed by the same amount, then such a system is called time invariant. If an advanced input is applied to a system and output also advanced by the same amount, then such a system is called time invariant. Okay, so thus we can conclude that the output and input are synchronized for the time invariant. Time variant means if the output and input are not synchronized, then it is called time variant. If you shift the input, then output is not shifted or output shifted by some other value, then also it is time variant. How to do the calculation of the time variant? To find the delayed response, we just delay yt minus t naught, replace all the t by t minus t naught. And to find the response of the system for the delayed input, t transformation of x of t minus t naught, write all the term inside the bracket and then shift it by minus t naught. For a system to be a time variant, there must not be any scaling and all the coefficient must be a constant. Any extra term output then input and output must be either zero or constant. It should not be a function of time. Time invariant system is not affected due to the presence of DC component in the input output relation. DC component are also referred as the initial condition. Time invariant of a system is never affected by amplitude scaling as well, because you are changing anything with the time, then only it will affect your time variant or invariant. Otherwise, amplitude change will not be going to affect your time variance. So time invariant of a system is not affected due to the presence of non-linear term. Non-linear term also not going to affect your time variant or invariant. Now the system becomes time variant due to the presence of any time coefficient term in the input output. Yes, suppose you multiply with the time function, then it will be going to changing your time variant and invariant of the system. And effect of basic operation, time shifting does not affect, time scaling operation make the system time variant, amplitude scaling does not affect, time folding make the system time variant. So this is the two things which are going to change. Shifting is not going to change your time variant and invariant, but folding and scaling will do. Amplitude folding does not affect, any operation make the system time variant. If you multiply with any time function, then definitely it is going to change. Static versus dynamic. So static system whose output depends only on the present input, then it is called static. Static system are also referred as memoryless because it only depends on the present. And dynamic means it can depend on the past and the future also, that is known as dynamic system. It is a memory system because it can store the future value and the past value. Causal system are those systems which depends on the present and the past inputs, and the non-causal systems are those systems which also depends on future. So both sided non-causal system, a system whose output depend on the future input sample along with the present input sample or past input samples both, then it is both sided non-causal system. Then a system whose output depends only on the future is known as anti-causal. And invertible and non-invertible, a system is said to be invertible if the output means the input of the system can be uniquely defined from the output of the system. Okay, if you define by the output of the system uniquely input, then it is a invertible system. Uh, for an invertible system, there is a distinct input must produce a distinct output. And invertible system, two different inputs cannot produce the same output. Obviously, if I am saying the distinct input means distinct output, then definitely two different input cannot provide the same output. Inverse system will always exist if the system is invertible, then inverse system will always exist. So if you suppose if I differentiate, I will get in after integration, I will should get the same function. Then only it is an invertible system. Okay, that means there should be a inverse system. Okay, guys, so thank you for watching this session. This is it from my side today. And here I have discussed with you about the basic signals and system. So, okay, this is all about the basic signals and system. I hope that it is useful because it quickly in the 1 hour we have discussed all the elementary signals in the all the classification of the signals and then all the classification of the system as well. Okay, thank you. And tomorrow we will discuss similar way. We will discuss about the Laplace, Z transform, etc. and Fourier transform, Fourier series. And day after tomorrow we will discuss discrete time Fourier transform and your filter and your fast Fourier transform. Those Fourier transform properties. These all we will be discussing in day after tomorrow session. Okay, thank you. Yes, Gaurav, thank you so much. Thank you so much for commenting here that EMFT is better. Yeah, means EMFT is good because I you have not seen me teaching signals, so that's why you are not knowing about the signals. But still, here I just in the YouTube we don't really teach nowadays. We give you the sort of series where some small concepts you learn. When you learn the whole signals and system, then you will understand the level of the signals and system also in my session. Okay, thank you.